Okay, so we're going to do some complex analysis. We're going to find where this function is differentiable. The function is z times the real component of z plus the conjugate of z. Now, the way to do this is using the Cauchy Riemann equations. So I'll just write that up here. Cauchy Riemann equations. Okay, so what it involves in is breaking this up into its component parts. So what we know is that z is x plus I, y. Now x and y are just the values of the real part and the imaginary part. So now instead of saying f of z, we can now say f of x plus iy. So let's just write that. So now break that up now into these components. So we've got x plus iy. Real z is just x. Then we add the conjugate. Or for the conjugate, we just flip the sign of the value of z. So z equals x minus iy now for this. So just put that in a little bracket here. That's x minus iy. Now all that remains to do is just to FOIL this across. X plus iy can go with that one, and the x plus iy goes with that one. Okay, so x times x gives us x squared. Iy times x is plus iyx. That's pretty straightforward. Now here we've got almost a difference of two squares. So we've got x plus iy, x minus iy. So that just becomes first term squared and the second term squared. So x squared and the iy squared. So iy times minus iy will give us positive y squared. Now when it's a positive and a minus multiplied together, that would normally be yielding negative, but when it's I, because I squared is minus 1, that then gives us two negatives and a positive, hence why we get the plus y squared. Okay, so now what remains to do now is just to simplify this up a little bit. So that then just equals 2x squared plus y squared. So that's our real part. And imaginary part is just iyx. Okay, so now before we do the partial derivatives, which is one of the main parts of the Cauchy Riemann equations, we're going to break this up into the next stage. So f of x plus iy. So what we do now is break this up into two sets of equations. So the first one is, we say u of x comma y. This is our real part. So actually let's just break this up a little bit. F of x comma y, let's just note this down first. That will then just become u times v of x comma y. So now all we can say is that u of x comma y is this one, and the v of x comma y is this one. So u x comma y in this case is the real part. So that's 2x squared plus y squared. And then our v of x comma y, that's our imaginary part, so we don't need to quote the I because we already know it's the imaginary part. So that's now just yx. Okay, so Cauchy Riemann equations, partial derivatives of each of these with respect to the x and the y. So we take the partial derivative of u with respect to x. So what is that? So with respect to x, the y squared becomes a constant, so that disappears. Then we just take the derivative of 2x squared, which is just 4x. Okay, now we'll take the partial derivative of v with respect to y. So here x is the constant and y is what we want to take the derivative of, so therefore we'll just end up with x. Okay, now here, take the partial derivative of u with respect to y. So the 2x squared will disappear. And then we just take the derivative of y squared, which will give us 2y. And now we take the partial derivative of v with this time respect to x. So here the y is the constant and x is what we're taking the derivative of, and that just becomes y. Okay, so now the Cauchy Riemann equations give us this, what we're interested in. So if this one equals this one, and then this one to equal the negative version of this one. So what we're looking for is where 4x equals x. So where does 4x equal x? That's basically what we're looking for. Well, the only value here that this applies for is when x is 0. So that's at x equals 0. And now here, where does 2y equal the negative value of this? So where does 2y, let's just write it like this again, where does 2y equal minus y? Okay, so again, the only place where that occurs is at y equals 0. Okay, so now we go on to what we can see is where this function is differentiable, and these equations have shown us that. So if I just wipe this out now, because we've worked all this out, let's just go along here. Just work on here now. So therefore, this function here, f of x plus iy, this is differentiable at point 0, 0. That's the only place you can differentiate this function. Now, there's other things we need to check first of all before we can actually just go for that as our actual answer. First thing we need to work out is, do all these partial derivatives exist on the complex plane? Well, 4x, x, 2y, y, they all exist. So we'll write on here du dx, dv dx, oops, make that curl, dy dx and dy, sorry, not dy dx, dv dx and du dy. So these must be concerned to y. There we go, now we've got it. So all the partial derivatives here, these all exist on the complex plane. So that's good. Next thing we need to know, is all these partial derivatives, are they all continuous at the differentiable point? Well, 4x and x, 2y and y, these are continuous everywhere. So these are all continuous. Sorry, let's not write it here. Let's write it across the side there. So they exist on the complex plane. They're also continuous at the point 0, 0. So therefore all the Cauchy Riemann equations are satisfied at 0, 0.